Hello science fans! Today we're following the incredible journey of Voyager 1 and Voyager 2, our robotic messengers to the stars. Launched in 1977, these probes gave us our first close-up look at Jupiter, Saturn, Uranus, and Neptune, transforming our understanding of the solar system. Their mission took advantage of a rare planetary alignment using gravity assists, like cosmic slingshots, to visit 4 planets in just over a decade. After their planetary tour, the Voyagers set out for an even bolder goal, to become the first human-made objects to enter interstellar space. Each probe, about the size of a small car, carried instruments to measure particles, magnetic fields, and cosmic rays, our eyes and ears in the darkness. And on board, a golden record, a 12-inch gold-plated disc with greetings in 55 languages, music, and images. A message in a bottle for any intelligent life that might find them. The golden record says, "This is who we are. This is where we came from." The Voyager mission is more than science. It's a human story, a symbol of hope and curiosity. These tiny spacecraft are still out there, traveling farther than any human-made object ever has. Their journey is a triumph of ingenuity and our thirst for exploration. They remind us that even the smallest messengers can carry the biggest dreams. Let's follow their path to the edge of our solar system. Where were the Voyagers headed? Beyond the planets into the vast bubble created by our sun, the Heliosphere. The sun constantly blows out a stream of charged particles called the solar wind, forming a gigantic invisible shield around our solar system. This heliosphere acts as a cosmic force field, protecting us from dangerous galactic cosmic rays, radiation from exploding stars, and other violent events in our galaxy. Without this shield, life on Earth would be exposed to much more harmful radiation. The edge of this bubble is called the heliopause, the boundary where the solar wind's push is balanced by the pressure of interstellar space. Imagine 2 winds colliding. The heliopause is where they meet, marking the true edge of the sun's influence. For decades, we could only guess what this boundary was like. The Voyagers were sent to find out, to cross into the unknown and report back. Their mission to touch the very edge of our world and reveal what lies beyond. The heliosphere defines our cosmic neighborhood and shields our planet. Understanding it is fundamental to knowing our place in the universe. The Voyagers' journey to the heliopause was a leap into the great unknown. They were our scouts, venturing farther than any before. What would they find at the edge? In August 2012, after 35 years, Voyager 1 made history. It crossed the heliopause and entered interstellar space. Its instruments detected a sudden drop in solar particles and a spike in galactic cosmic rays. Clear signs it had left the sun's domain. 6 years later, Voyager 2 crossed the boundary at a different location, confirming the heliosphere isn't a perfect sphere. It breathes and shifts with the sun's activity. These crossings gave us our first direct measurements from interstellar space. The data traveled over 20 hours at light speed to reach Earth, picked up by NASA's Deep Space Network, like a whisper from across the solar system. What the Voyagers found was astonishing. The region beyond the heliopause was turbulent, complex, and much hotter than expected. The discoveries challenged our theories about how the sun interacts with the galaxy. Instead of answers, we got new, even bigger questions. The final frontier turned out to be stranger and more wonderful than we imagined. The Voyagers' journey redefined our understanding of the solar system's edge. They proved that exploration always leads to the unexpected. Their data is still changing science today. What secrets did they uncover at the boundary? One of the most dramatic discoveries, a wall of fire, at the heliopause. As the Voyagers crossed into interstellar space, they measured plasma temperatures between 30,000 and 50,000 Kelvin, hotter than the sun's surface. This heat comes from the solar wind slamming into the denser interstellar medium, creating a shockwave and a region of intense compression. It's like a cosmic traffic jam. Particles energized to extreme speeds. The wall isn't fire as we know it. It's a thin, superheated plasma, not a solid barrier. The region is both incredibly hot and highly magnetized, a turbulent, fiery boundary where 2 cosmic forces collide. This discovery changed our picture of the heliopause from a simple line to a thick, complex, and scorching hot layer. The wall is the sun's last gasp before the cold, dark galaxy takes over. Yet despite the heat, the region is nearly a perfect vacuum, almost nothing there to touch you. The wall of fire is a vivid reminder of the strange physics at the edge of our solar system. It's a boundary unlike any other. So how did the Voyagers survive flying through a 50,000 Kelvin wall of fire? The answer: temperature isn't the same as heat. The plasma is extremely hot, but it's also incredibly thin, almost a vacuum. There are so few particles that they can't transfer much heat to the spacecraft. It's like sticking your hand in a hot oven's air. Briefly, you're fine, because the air is thin, unlike the dense metal rack. The emptiness of space saved the Voyagers. They passed through the wall without harm. Their survival is a testament to both the strange physics of space and the robust engineering of 1970s technology. Built to withstand radiation and cold, the probes were tougher than anyone imagined. The wall of fire was no match for their sturdy design. Sometimes the universe's weirdness works in our favor. The Voyagers also uncovered a magnetic mystery at the heliopause. Scientists expected the sun's magnetic field to point differently from the galaxy's field outside the bubble. But Voyager 1 found the fields were almost perfectly aligned, so surprising some doubted it had crossed the boundary at all. When Voyager 2 crossed at a different spot, it found the same thing: the fields matched. This forced scientists to rethink how the sun's magnetic bubble interacts with the galaxy. It suggests some unknown process is connecting the fields, maybe even magnetic tunnels allowing particles to leak in. Magnetic fields shape galaxies and protect planets. Understanding this connection is crucial. The Voyagers revealed a cosmic puzzle we never expected. Future missions will have to solve this magnetic mystery. Why does any of this matter? Because it's about understanding our home's place in the universe. The Heliosphere is our shield against cosmic radiation. Knowing its structure helps protect astronauts and future explorers. The Voyager's discoveries are practical science, vital for space travel and for understanding the forces that shape our world. But their story is also deeply inspiring. Two small probes, launched nearly 50 years ago, are still sending data from the interstellar void. They remind us what we can achieve when we explore the unknown together. Every day they travel 1,000,000 miles farther, carrying our golden message to the stars. Their discoveries have reshaped our view of the solar system and opened new mysteries. The universe is more complex and beautiful than we ever imagined. The Voyagers connect us to the cosmos and to each other. We are all crew members on this little planet, traveling together through a vast universe. Let's keep exploring.